So we'll get started now. Today in this lecture, we're planning to cover quadratic equation. We'll quickly go through the basics and then do some questions. And we'll also look at inequalities and whether we'll do a bit of inequalities. Basically, we'll look at polynomial equalities and method of intervals and then do questions around that. It's not a very heavy material. There is not a lot of material today, so hopefully we should be able to get through it fast, but this material is important because combined with what we studied in the last session, which was around functions, we would start seeing these are the basics which would help you solve all the questions. So let's start. This is fairly basic, so you guys, most of you know how to do it. You should know both how to do it by formula and by factorization. If you have to solve a quadratic equation, x squared plus 6x plus 8, so this you should be able to do mentally itself, and you should not be even writing these steps which I am writing. So but just in case some people tend to forget the method of factorization and just use the formula every time, it's not the right way, because many a times this will be much quicker. So you should be comfortable with both these solutions. And here you will apply the formula minus b plus minus b square minus 4ac by 2a. And you can apply yourself. I am sure you guys can apply. Just pointing out discriminant d is equal to b square minus 4ac. And this term is extremely important, as we will see later on in analyzing quadratic equation. So you should be, one thing also you should practice is being able to calculate b square minus 4ac without any mistake mentally itself. That will help you do things faster later on. We'll just quickly look at how quadratic graphs are formed. A lot of you know it, some of you do not know it. Here we are looking at, we don't need to plot anything, you need to know the shape of the graph. And the way to do it is this. So if the function is of the form ax square plus bx plus c, then if a is greater than 0, then the graph will open upwards. So it will be a parabola kind of a shape, and the graph will open upwards. While if a is less than 0, then the graph will open downwards. The other thing you need to know is if discriminant is greater than 0, then the graph will cut the x-axis at 2 points. If the discriminant is less than 0, the graph will not cut the x-axis. And if the discriminant is equal to 0, the graph will just touch the x-axis. So these are the three cases. And based on this, you can at least get a feel of how the graph will be. For example, one more thing before we move on. The graph will also have a minimum point or a maximum point. So if a is greater than 0, the graph will be of the form upward looking parabola. Then it will have a minimum point and the maximum will be infinity. While if a is less than 0, the graph will be a downward looking parabola. And then the graph will have a maximum point and the minimum will be equal to minus infinity. So whether it have a minimum or a maximum, that point's coordinates are given by minus b by 2a and minus d by 4a. For example, if the expression is 2x squared plus 5x plus 10 equal to 0, and you have, so here a is greater than 0, 2, so this will be a upward opening parabola and will have a minimum point. And if you are asked to find the minimum value, so at x is equal to minus b by 2a, which is minus 5 by 2 into 2, this function will have a minimum value of minus 5 by 4. And the minimum value will be minus d by 4a, which is equal to, here you can calculate the minimum value. So what will be the value of the function? What will be the minimum value of this function? Sorry, I should not have written equal to 0 over here, because it's a function, and function gets defined by y equal to 2x squared. So in which case the minimum value of the function here will be minus d by 4, and d is b square minus 4ac. So you can calculate 25 minus 4 into 2, 8 into 2, 8, 80. So 25 minus 80, which is roughly 655, and divided by 4a, or a is 8. So the minimum value of this function will be 8. From here also you can see that since this is 55 by 8 and it is the minimum value, the function will definitely ever be negative. This function is always going to be a positive function, and you can do that by also plotting that and various other ways we'll see shortly. So This is basically how you draw the graph. We'll just draw a couple just to get comfortable with them. X square plus 4x plus 3. What do we know? The coefficient of x square is 1, which is positive. So the graph will open on the open upwards. And then discriminant is equal to 4 square minus 4 into 3, which is equal to 4. So discriminant is greater than 0. So it will cut the x-axis twice. Now it may cut this way, it may cut that way. For that, we'll need to know the solution. These points are the solution of the equation. So if you equate this equal to 0, and this one is an easy one, you can get the two solutions, which will be, you can divide x square plus 4x plus 3 into x plus 3 and x plus 1. So minus 1 and minus 3 are the solutions. This is minus 1, this is minus 3, and probably this line will be here. So this is the graph over here, and from the graph you can tell various things. The function is negative between minus 3 and minus 1. Between minus 3 and minus 1 the function is less than 0, and minus infinity to minus 3 and union 1 to minus 1 to infinity, the function is greater than 0. So you can do these kind of analysis fairly quickly looking at the graph, and if there are two graphs it becomes much more easier. Similarly, let's draw this one as well. Here we have a equal to minus 2, which is less than 0. So the graph will be of this sort, looking down. D is equal to b square. So minus 2 square minus 4 into minus 2. And you should not be writing all this stuff. This you should be able to do mentally. 4 plus some number, 24 into 8. So this will be greater than 0. That we for sure know over here. So we can say this will be greater than 0, and hence it will be cutting the axis twice. So the graph will be of the sort, a downward curve which cuts the axis twice. Now again we need to find these roots to know the exact location. You can do it if your question requires. If the question doesn't require, you don't need to. So if you do this, x square plus x plus 12, and I've chosen questions with easy roots because it's easier to, I just want to explain the concept here. Minus 12 and then plus 4x minus 3x minus 12. So this will have x plus 3 and x minus 4 as the root. So this will be minus 4 and this will be 3. The line will be somewhere in between. This will be x. If you want to find this point, which is the maximum point, again you need to remember the formula. Minus b by 2a will be the x value, which is equal to, in this case, minus of minus 2 by 2 into minus 2, or 1 by 2. And y for that same will be minus d by 4a. These formulas you should know, and you should have them on your fingertips. So I won't calculate this, but you can calculate and see whatever is the y value. So knowing these graphs is extremely helpful. They may not ask you directly about a question regarding these graphs, but knowing them will help you solve questions on functions, on quadratic equations, and so on. Just bear in mind whatever we learned last time. If you were asked the graph of, so now we know this, I'll just erase it a bit, and then if you are asked to draw this function, you should not panic. Now you know how this function will work. If you have revised the last session, it is just a fairly straightforward thing. This function will be this part and then the other part reflected upwards. So this was the kind of graph which this function will have. And same way, if you wanted to draw, let's say we replace x by mod x. So if you needed the graph of this sort of a graph, then again you have just replaced x by mod x. X square and mod x square will remain the same thing, and this also we know how to draw, right? Last time we had seen that we just reflect whatever is on the right hand side to the left hand side. So if the right hand side looked something of this sort, it will just again be reflected here, and you'll have your points will be 3 and minus 3. So all these things we have done it earlier. If you are finding it more difficult to understand how this is happening, or you are not quick enough, then you need to revise the previous part, and that's how concepts get built up and to generate speed. Your and I keep harping on this point, your speed would not come by learning a few extra formulas or tips or tricks. It would come by knowing the basics so well that you're not even thinking about it. You don't need to think whether minus d by 4a tha ki b by 4a tha, was it minus b by 2a or minus b by a. All these things should be on your fingertips. As soon as you see the question, all these things flash in front of your eyes and you know which one to pick where. So for that, it requires a bit of practice. Let's do a few questions. We'll very quickly look at the questions. Here we are asked, how many solutions will this equation have? Now, mod x, we know at least, so we can do this very easily. If x greater than 0 or if x less than 0. If x greater than 0, this equation is minus 7x minus 18 equal to 0. If x less than 0, this equation becomes x squared plus 7x minus 18 equal to 0. Now, you can find whether this will have two solutions or not, but those two solutions need to be positive for the function to be, for those solutions to be valid. So let's see here, how can we do it? One is you find the solutions and then go ahead and do it. But generally, when you get a question like that, finding the solutions would not be very simple. They will make it difficult for you. But you can try a few things and we'll learn that very shortly. I think the next slide is that, but we can use it here and we'll see. So sum of roots for a quadratic equation is minus b by a. So that will here be minus of minus 7 by minus 1, which is equal to 7. Product of roots is c by a, which is minus 18 by 1, which is minus 18. So sum is 7, product is minus 18. And does it have, let's just check the discriminant also very quickly. 7 square plus 4 into 18. So this is greater than 0. So the equation has two roots. Their sum is 7 and product is minus 18. Given that the product is negative, it means it has one positive and one negative root, right? And the sum is positive. So the product positive root is probably greater. So there will only be one positive root that this equation has, which is what we need. We need only those roots which are greater than 0 because our binding condition is x greater than 0. So based on this, you can say that from this side we'll get only one positive root. On the other side, we're looking for negative roots. And let's see what is the scene here. So discriminant here will be the same. So d will be greater than 0. So this equation does have two positive roots. And then sum will be equal to minus 7 in this case. And product is still minus 18. Again, the sum is negative, which means just that the negative root will probably be bigger than the positive root in absolute value. But the product is negative, and that gives us tells us again that one root will be positive and one will be negative. Using that, you know that there will be one negative root from here. So overall, this particular equation will have two roots. This will have two roots. Ideally, I think you can do it by, I'm pretty sure you can do it by graphs also, although it's not, I'm not showing that method here because it's not very natural for us. Doing this is fairly straightforward because we do this in a lot of questions, x greater than 0, x less than 0. You can, if you want to do it graphically, I'll just illustrate. You can try it yourself if you want. Just plot x square minus 7x minus 18 equal to 0. That will be step 1. Step 2 will be just replace, do this modification x to mod x, and then 3 count how many times it crosses x-axis, right? So I think you'll get 2 as the number there also, and it would be as straightforward. It would actually be quite faster than what we did. Even what we did is not very time taking. So using this method also you can solve the question. So we used this result previously. I'm introducing it right now. This is very important. I think from what I have noticed, I'll just check. I just noticed I'm not looking at your comments, etc. But in the sense, voice is breaking. I'll just wait over here for a minute. I wasn't looking at your comments. I'm sorry about that. Is my voice still breaking or is it fine right now? Can you guys hear me? I'll wait for a couple of minutes here. Okay, okay, that's great. I'm having a bit difficulty looking at the comments in this section because I think it shows me only 4 or 5 at one go. So if I miss your comments, I'll answer them later on post the class. So if you have any doubts at any point, keep posting them. I'll look at it after the class is over and I'll reply to those comments. So nothing to be concerned about. So here we have the sum and the product of roots, and it's very important that you know these relations well. From what I also looked at whatever questions have been asked on quadratic and equations and so on from previous years, and I went back like 20-25 years. What I noticed is that most of the questions are asked based on these kind of relations. They do not ask very complicated stuff in quadratic equation because they know that a lot of students might not have done that as properly in their 11th and 12th. But this relation is introduced in 9th and 10th, and this is where they harp on. They use slightly complicated problems using these relations itself. So it's important that you know them fairly well. You know how to solve questions using these relations, and then go and apply them. So sum of roots minus b by a, product c by a, for a quadratic equation. This can be extended further as well, and questions do come. So if it's a cubic equation, the sum of roots taken one at a time is minus b by a. Sum taken two at a time. So if it has three roots, then alpha 1, alpha 2 plus alpha 2, alpha 3 plus alpha 3, alpha 1 is equal to c by a. And then the product of all three, which is alpha 1, alpha 2, alpha 3, will be equal to d by a. And you can keep extending this to as higher equation as like if it were x to the power 4, the sum will be minus b by a, sum taken 2 at a time will be c by a, product sum taken 3 at a time will be minus c by a, minus d by a, and then product will be e by a. So this you should know, and as soon as you see a big equation x to the power 4, x to the power 5, you should know that you can apply these things, and probably the question will be solved using some of this thing. Let's see a few questions, and all these are CAT questions. I think the previous two were not CAT questions, but these are definitely CAT questions. So ax square plus bx plus 0 is a quadratic equation with rational coefficients such that a plus b plus c equal to 0. Then which of the following is necessarily true? And they have written 3 or 4 lines, and you need to find which one was right. I think only one correct. You don't need to worry about. If you get one answer, you don't need to worry about it. So first thing, what do we know? A plus b plus c equal to 0. So if x is equal to 1, a plus b plus c equal to 0 will be the case, right? So as in, what I'm saying is that this relation tells us that x equal to 1 is a solution. Because for x is equal to 1, this function will be a plus b plus c, and which will be equal to 0 as we know. So x equal to 1 is a solution for this particular equation. One of the solution is x equal to 1. At this point, this was the only insight needed to solve this question. There wasn't anything more fancier than this required to solve this question. Then you can solve both the roots of the equation are less than 1. No, because one equation is solution is 1. One of the roots of the equation is c. So there, product of roots is c by a, which is equal to 1 into the, sorry, I'll just do that. 1 into the other root. So the other root must be c by a. Other root equal to c by a. So the two solutions are 1 and c by a. And one of the roots of the equation is c by a is probably the answer. Exactly one of the roots is 1. So again, using this, you can solve this question probably if you didn't solve this question in the exam, people would have lost out on marks. Those 4 marks would have been crucial, and it required just a quick insight. It didn't require a lot of knowledge, a lot of analysis, a lot of solving very difficult question. And that's the problem which people who prepare a lot have actually. They start thinking in terms of more difficult question, while many a times the questions are much more simpler. So this question, if I had to categorize, would be in the range of moderate difficulty. It won't be very easy because it requires one bit of observation, but it won't be considered very difficult as well, because the moment you notice that, you can solve it and get those marks. Let's look at the another question. So here we have given that a function attains its maximum value at x equal to 2. What would be the sum of roots? This one would be an easy question. It again came in the exam. It's not like I'm doing it for practice. It was a proper question. I think it's a more recent question as well. It's not like it's very old, 2013 or 12 or something like that. So the exam, I think also they are moving towards slightly easier papers in quadratic, in quant in general. But even at that level, this question would be considered an easy one. Maximum value at x equal to 2. So it's not needed in this question, but if you should have made this observation that in this question a will be less than 0, because if a quadratic function is attaining a maximum value, its graph would have been like this. That's when only it will have a maximum value. If it were like that, then maximum value would have been infinity. And in this to get this kind of a graph, you need a less than 0. So in this question it isn't asked, but other questions they might ask something based on this observation. But here what it says is it attains maximum value at x equal to 2. We remembered the formulas that we're looking at. We knew that minus b by 2a is the value at which it attains its maximum. So minus b by 2a is equal to 2. What would be the sum of roots? And we know sum of roots is equal to minus b by a. So if you know minus b by 2a, minus b by a is just 2 into 2, which is equal to 4. So the answer will be 4. Okay. So straightforward question, straightforward 4 marks, or however it would have been in that exam. Just knowing this, you should be able to solve these questions. But overall, that's what I'm saying, that they've halved a lot on sum of roots, product of roots, and so on. So if you're not able to think through, if you get a quadratic question in the exam and you're not able to solve, at least think along these lines. If you have tried everything else, can I use sum of roots or product of roots or something like that to solve? Because I've noticed there are a lot of questions where they're using this. Use it as the last resort. I won't advise going in with this methodology कि quadratic है तो sum of roots कहीं question होगा, अभी उसी से लगाता हूँ. But कुछ ना समझ में आ रहा हो तो you can try that. I put this in last minute, so I'm not sure whether I copied the question correctly. But let's see. If one root of x square plus px plus 12 is 4 and the equation has equal roots, then the value of q is. So again, this was asked in CAT. This again, moderate difficulty, I would assign it as a moderately difficult question, not very difficult if you are aware, if you're not scared of algebra. So x square plus pi a px plus 12, one root is 4. The product of roots here is 12, c by a, which is 4 into the other root. So you know that other root is equal to 3. Of course, I'm writing this, you don't start writing this in the exam. You know this. Just by looking at the equation, you know that the two roots are 4 plus 3, 7. The sum of roots should be equal to minus p by 1, which is equal to 7. So you know p equal to minus 7. This you know even before starting the question. You should just look at this and you should know that, okay, p is equal to minus 7. So the second equation becomes x square minus 7x plus q equal to 0. Now the equation has equal roots. So you know, again here, sum of roots minus b by a. So sum of roots is 7 in this case, minus 7 by 1, which is equal to 7. And hence you can find q because the equation has equal roots. So if both roots are equal, then their sum 2 alpha is equal to 7, alpha equal to 7 by 2, and hence q product of roots here will be equal to minus b by a, or c by a, sorry, equal to q, which is 7 by 2 square, equal to 49 by 4. So again, relatively simple, not very difficult, can be solved, should be solved. If you are a serious aspirant, you should be getting this question correct. We'll change tracks a bit here. We'll come back to solving some of the quadratic questions, but we'll just cover method of intervals here. I'm not sure how many of you know it, how many of you know it properly, and so on. So we'll just cover it quickly. So it's a method of solving polynomial inequalities. Not a lot of questions come, but they do come in application. I think you might get into a question where you need to use it. So the way to solve is fairly clear. There are straight steps on how to go about it, and I would request you just watch another video also just to get get the formal terminology for these steps, because I have written them using my own language. But what you need to do is this: bring all expressions to one side of the inequality, all the x-related expressions to one side. You can put all expression to 0 to find a critical value. So in this equation, we'll put all of them to equal to 0 to find the critical values. But before doing that, you need to ensure that all values, all coefficients of x are positive, which we have here. All these coefficients of x are positive. Ignore terms which are always positive or always negative. So x square is a term which is always positive, right? So we should ignore that. You should not consider that while getting your critical values. X square plus 2x plus 4. Here a greater than 0. So upward looking curve, but d is equal to 2 square 4 minus 1. So d is less than 0, which means it will be an upward curve which will never touch the x-axis. So x square plus 2x plus 4 will always be positive. So both these terms can be excluded, and you equate the other expressions equal to 0 to get the critical values. So here the critical values will be x plus 1 when we put equal to 0, minus 1, same way minus 2 and minus 5. So you have minus 5, minus 2 and minus 1 as the critical value. We have ignored x square, we have ignored x square plus 2x plus 4, and you should know why. Once you have the critical value, just plot them on a number line: minus 1, minus 2, minus 5. And then you can start from the right hand side. This one will be plus, and then you keep alternating your sign. And wherever you have a positive sign, those are the areas where this expression is positive. So x element of minus 5 to minus 2, union minus 1 to infinity. In these areas, this expression will be positive, and x element of minus infinity to minus 5, union minus 2 to minus 1. These areas it will be negative. It will be equal to 0 at the critical values if the expression which got you that critical value is in the numerator. If it's in the denominator, it won't be defined. So for this function, it will be 0 at x equal to minus 1 and minus 2, it will be equal to 0. At x equal to minus 5, not defined. So bear that in mind. Many times people make mistakes using while solving using this. So keep that in mind. Let's do one more question. 2 by 5x plus 3 less than 1 by x. How would you solve? And a student has been asking me, so I'll just repeat, although most of you should be knowing this. You cannot multiply this by x. And the reason why you cannot multiply by x is in an inequality. If you multiply by a negative number, the sign of inequality changes. So when you are multiplying by x on the other side, you do not know whether x is positive or negative. So that step you cannot do. If you really want to do it, it will be much more cumbersome. You'll have to say that if x is greater than 0, then do not change and solve it separately. If x is less than 0, then change it and change the sign. So it will become much more cumbersome. So ideally, if it's an algebraic expression, you should not be multiplying it on both sides of an inequality. So we'll take it as a subtraction. We'll take it on the other side as a subtraction. So this equation becomes, just a second, 2 by 5x plus 3 minus 1 by x less than 0. We brought it to this side. You can do all the, we'll take the LCM, do the subtraction. This becomes 2x minus 5x minus 3 less than 0, which becomes minus 3 minus 3x by 5x plus 3 and x. Now here we can do the critical values and stuff, but you remember there was a clause in there that the coefficients of x should be positive. Here we have coefficient of x as negative, so we'll need to multiply with minus 1 on both sides, and the only thing that will happen due to this is here we will get 3 plus 3x. So we have taken a minus here and multiplied with a minus 1 on both sides, but that will change the sign. So this becomes our final thing. Now we can solve this, right? We just put each term equal to 0. So from this one we get 0, this one we get minus 3 by 5, and this one we get minus 1. So you just plot them on the number line, 0, minus 3 by 5, minus 1. Start from the right hand side, plus, minus, and wherever it is plus, that's your answer. So x element of minus 1, minus 3 by 5, union 0 to infinity. So this is basically how you solve inequalities using method of intervals. This one is a slightly more trickier one. It doesn't need method of intervals, but it requires you to understand mod x and keep doing such questions again and again, so you can understand that mod x seems to be a pretty important function. So especially from examination perspective. Mod x minus 2, mod x plus 5, again we'll do it the way we have done it before, x greater than 0, x less than 0. If x greater than 0, the equation becomes x minus 2, x plus 5 less than 0. If x less than 0, it becomes minus x minus 2, x plus 5 less than 0. And then you can solve it using method of intervals itself, or anyway, you know how to do it, I think now. The critical value is minus 5, 2, plus, minus, plus. So the answer here is x element of minus 5 comma 2. So minus 5 to 2 is the solution, but you can only take values where x is greater than 0 because that was your starting condition. So combining with that, you get answer which is x element of 0 to 2. And same way on this side, we have minus x minus 2, x plus 5. We need coefficient of x is positive, so we'll multiply by minus 1. So this becomes x plus 2, x plus 5 greater than 0. The roots are minus 2, minus 5, plus, minus, plus. And so the answer becomes x element of minus infinity to minus 5, union minus 2 to infinity. We need to take only those values for which x is less than 0. So it becomes x element of minus infinity to minus 5, union minus 2 to 0. 0 we should include on one direction, either here or here. So maybe we put it here, equal to 0, less than equal to 0. And then we'll get our equation as this. Yeah, so you should, sorry, we won't get it here. That's what I'm getting confused myself. So this is for x greater than equal to 0. So when you put this condition here, you will have to include 0 as well, because this is equal to 0 is included that side. And this side you just get minus 2 to 0. And then you can combine both these to get the final answer. So minus infinity to minus 5, union minus 2 to 2. So this will be the answer for this inequality. So this kind of question, it requires a bit of effort. You can expect such questions because they require some effort. They don't require a lot of effort, and you should be able to solve them also. Now practice once or twice by writing it down if you find it is a bit trickier than what you anticipated. If you find it very straightforward, then no point, you can take it easy. Similar question, again we can solve it similarly. I think I'll leave it for you guys to look at it yourself, but just do this: x plus 3 greater than 0 and x plus 3 less than 0, and then whatever you get, solve for that. So if you put it as greater than 0, then you get x square minus 3 greater than 0, and you can solve this. And if you put less than 0, then you get x square minus x, x square plus x plus 3 plus x greater than 0, or x square plus 2x plus 3 greater than 0. And this will be valid for x less than minus 3, and this will be valid for x greater than minus 3. I think now I'm going about it, I'll just solve it itself. X square greater than, so x square minus 3 greater than 0. If you want to use the same method, you can just x minus root 3, x plus root 3 greater than 0. You can again plot here minus root 3 plus minus plus. So the solution here is minus infinity to minus root 3 to infinity. We need the solution which is greater than, let's include equal to this, greater than equal to minus 3. So combining those, your answer here will be minus 3 minus root 3 union root 3 infinity. And from the other side, you need this expression to be greater than 0. Uh, Here again, I think a is greater than 0 and d is less than 0. What that means is that the curve will be opening upwards and will never touch the axis. It will be something like that. So this expression is going to be always greater than 0. This is always positive. So for all values of x less than minus 3, this expression is greater than 0. So here your answer is minus infinity to minus 3. So you need to combine these two solutions, and combining them you will get minus infinity to minus root 3 union root 3 to infinity. I hope I didn't make a mistake, but otherwise you can solve it in this way. So I'll just take a brief pause over here. I think we have a few more questions to cover, and then I'll also take if you have any doubts and etc. But I'll just take a couple of minutes. If you have some more comments, if you have some doubts, some questions, feel free to put them in. I'll try and read them right now so that we can answer them. And then in 10-15 minutes, we'll cover the remaining questions. I think there are 3, so it should not take a lot of time. In fact, some of you, if you want to try, you can try this also, what we have on your screen right now. And I'll just start on in like 1 or 2 more minutes. Yes, Pranendu, two upward parabolas can intersect at 2 points because their slope will be different. No. I think we'll start with this now. So in this question, what we have been given is an expression x square minus 11x plus pot p equal to 0. And we have to find, will the equation have integer, for all values of p, will the equation have integer roots? So let's find the roots first. And here we'll have to calculate the roots. So b plus minus b square, which is 121 minus 4 mod p by 2. So we need this value to be an integer. And for this value to be an integer, you need 11 plus minus root 121 minus 4p to be even. And this means 121 minus 4 mod p should be odd because we are adding and subtracting to an odd number. So this number should be an odd number. Mod p will always be positive. So it means 121 minus and minus 4 mod p should be a perfect square of an odd number. Odd number? Yeah, of an odd number. So how many odd number squares can it take? This is 11 squares. So 121 is fine. I think all the ones still 9 square 81. So minus 4p will be put p equal to something, and we'll get this 7 square 49, 5 square 25, 3 square 9. So for all these numbers, you can get integer values. So 4, 5, 6, and for each we'll have a value of p. So 6 values, and since p will have a plus and a minus, for example, if we want to get 81, we'll need 4 mod p equal to 40 or mod p equal to 10. So p can take plus 10 and minus 10. So that way, for each of these values, we'll have 2 values of p, and hence 1, 2, 3, 4, 5, 6, total 6 into 2, 12 values. Deepak is saying only 8 values. So did I make some mistake? Deepak is writing some values there which seem like 8. I have 12 here. I hope I didn't miss anything. We'll see. If I make a mistake, I'll come back and correct. There's this question here. 2x minus 5y plus 19 square plus 3x plus 5y minus 34 square equal to 0. You need to find y minus x. Now, it's not exactly a quadratic equation, but I thought it's important to expose you to such questions. It's just a small trick involved. Better to know it than not know it in case something comes. It's the sum of two square numbers, right? So the equation is equal to 0 and it's a sum of two square numbers. Square numbers will always be positive. So neither of this can be greater than 0 because the other one cannot be negative to balance. So both of these will have to be equal to 0. So using that, you can find y minus x. So if this is there are a lot of questions like that. So that's why it's good to be exposed to such stuff. 2x minus 5y plus 19 equal to 0. 3x plus 5y minus 34 equal to 0. So you can solve these and get y minus x. Okay. Solve for yx and then get y. Similarly, if you get such expressions also, and I think I've seen some questions from x square plus mod y minus 2 is equal to 0. Again, mod function will not be negative, right? And x square will also be not negative. So here again, you can say that x square equal to 0 or x equal to 0 and mod y minus 2 equal to 0 or y equal to 2. So whenever you get an equation like that, which has positive numbers and they are summing up to 0, you should know that each term individually can be equated to 0. This is only if all the numbers are positive. So, and it can be done in various ways. You can just say that the numbers are positive, or it can have these kind of expressions. It can have expressions which are not very obvious to see, but are still always positive. What we saw earlier, x square plus 2x plus 4, this expression will always be positive. We know that because here d is less than 0 and a is greater than 0. So this expression will always be positive. So x square plus 2x plus 4 plus y square plus 3 equal to 0. And then you might be asked to calculate x cube plus y cube value and all this kind of stuff. So you know that whenever you see an equation where a lot of terms are summing up to 0, just check if there is something like that going on. Here you can always equate x square plus 2x plus 4 equal to 0 and y square plus 3 equal to 0. Okay, I didn't create the question point very well because y will have imaginary values and so on, but you get the idea that you should be able to do it. And it's not only two expressions, there might be more than two expressions, x, y and z might be there. We can always include plus z equal to 0 and so on. So just to ensure that you you are looking out for such stuff. These are the kind of stuff which actually make and break for the people, for people who have prepared very well. If you have prepared very well, there is no reason why, especially in quant, there is no reason why you cannot be at least 99 and above. The reason why people who could have got a 99.9 end up getting a 99.4 or a 99.2 is because of these kind of questions. एक दो question ऐसे you just get and you couldn't think of the trick, or you just your brain wasn't functioning at that point of time and you just made a mistake. And उसके लिए, and to avoid that kind of a situation, a few things are required from right now. You need to, one, practice hard, especially if you haven't done a lot earlier. If you are a JEE top ranker, you probably don't need to practice hard because you did all the practicing beforehand. You did it all in 11th and 12th, and now you just know it like the back of your hand. But if you didn't do it at that point, now you need to practice hard so that you know all the inks and outs. Knowing a question is one thing, recognizing it just by looking at it is different. And so for that, you need to practice a lot. Second is also whenever you're practicing, keep ensuring that you are trying to you are working under some kind of a time pressure. It's very easy to solve questions when you have 15 minutes to solve one. It's much more trickier if you have 3 minutes and you have to make a decision on whether you are going to solve or not. So ensure that you are working under some time pressure. Know all your formulas very well. Whatever you are doing, just know them. You should not like be thinking minus, as I said earlier also, minus b by 2a minus b by 4a and all that. You should just know that कि अच्छा हाँ इसका तो माइनस बी बाई 4 होता है. नॉट कन्फ्यूज कि सम ऑफ रूट्स माइनस बी बाई ए होता है या फिर सी बाई ए होता है एंड ऑल दैट काइंड ऑफ थिंग. ऑल दैट यू शुड नो वेरी वेल बिकॉज ऑल दिस स्मॉल बिट्स एड अप इन improving your speed, improving your concentration, reducing your mistakes, ensuring that you have more time for the tougher question when it comes. So all that helps you ensure कि you are in the 99.9 and the 99.95 and not the 98.3, where it is okay but it's not good enough if you have worked so hard for 1 year and so on. So वो सब थोड़ा सा, and that part is important. I can solve 10 questions, but you will be solving 50 questions or 100 questions at home, and that's where if you don't do it properly, this won't help. I'll be teaching the same thing to every student, but still some will get a lot more marks than others, and it won't be because they were very intelligent or they're very talented. It's just that they would have prepared well and they would have put in enough hours, either today or in their 12th or in their 10th. Some point they have put in the hours. So it's just a mixture of those things. So we have, at least on a theoretical basis, we have covered most of what is required in quadratic. One topic which I haven't covered, I might cover some other time, is common roots. Well, I think if two equations have one common root, what to do. If two equations have two common roots, how to identify. If three questions have three common roots, how to do that. We'll have a look at that. I think it is reasonably important also to have a look, at least for the quadratic one. Inequalities is not only what we have covered. There can be different things also in inequalities. So you should not assume that everything in inequality is covered. What we have covered is for polynomials and so on, but logarithms, sine functions, trigonometry function, I don't think they'll ask, but logarithm they might ask. So logarithm inequalities we haven't covered. I don't know. I didn't see a lot of interest for a course on for an hour session on logarithm, so I'm not going to conduct that. I haven't seen a lot of questions also, so it might not be that risky. But then log is a syllabus which is covered before 10th, so there is no reason why they can't ask. And we'll do some more difficult questions across algebra in another session. So that is mostly what I had for today. I do not know how many people listened in, but if you have any feedback, anything which we can do to improve, please let us know. If you do not think this is useful, please let us know definitely, because if it is not useful, I would rather spend my Sunday doing something else. So thanks a lot for attending, and looking forward to any suggestions you have. Thank you.